Hi guys, so in this video I'll be talking about Blelloch scan. I'll not explain the algorithm itself because I feel that there are really great video tutorials out there on YouTube that explains this algorithm. But what I found missing in those videos is that they don't explain the details like why this algorithm actually works. So when I first understood this, when I first saw this algorithm, it felt like magic to me, but it's not really a magic, and that is what I'll try to demystify in this video. So towards that, I assume that you already know what this scan is, what the algorithm is, what is reduction operation, what is downsweep, and I'll start with that assumption in this video. I'll start with the sequence of 16 elements and I'll show why this algorithm works on these 16 elements, right? So first phase is reduction. I'll just quickly complete that reduction. So we have some of these two elements, these two elements, these two elements, right? So we have some of these two, which is 10, these two, which is 26, these two, which is 42, and these two, which is 58, right? Then we have some of these two, which is 36, and some of these two, which is 100. And this operation, which is sum of 36 and 100, is not actually used anywhere, but I'll compute it nevertheless. Right, so this is the downsweep operation. Sorry, this is the reduction operation. And the next phase is the downsweep, which is really the tricky part. So I'll explain what this algorithm does from the top level, and then I'll do the algorithm mechanically. Right, so what this algorithm does is it splits this sequence into two halves, right? The half would be here. Then what it does is it computes the prefix sum for the first element of the first of the each sequence, right? Each partition. So first element of this partition is 1. It computes the prefix sum of 1, which is just identity, and it also computes the prefix sum of 9, right? Once we have those prefix sums, it divides these two halves again into two equal halves. So this half of 8 elements gets divided into two partitions, 4 and 4. Again, these 8 elements gets divided into 4 and 4, and then it computes the prefix sum of new boundaries. So new boundary is here. So it computes the prefix sum of 5 and it computes the prefix sum of 13, right? So how do you compute prefix sum of 13? So for that, what it does, it already knows the prefix sum of this guy, right? Prefix sum of 9. So what we can do is we can add sum of these four elements into this prefix sum to get the prefix sum of this thing. Okay. Similarly, to get the prefix sum of 5, we can add sum of these four elements into prefix sum of the first element, right? To get the prefix sum of this element. Okay. Similarly, after this step, what it does, it divides into another subsequences, right? Subpartitions. So these four elements, division happens here, here. For this four elements, it happens here, and for this four elements, it happens here, right? So let's look at this guy. How would you compute the prefix sum of 15? You take the prefix sum of something that is known, that is prefix sum of this 13 is already known, and you add these two elements, sum of these two elements, which is you already computed in the reduction phase. You add that to this number and you get this number, right? Prefix sum of 15. Similarly, for prefix sum of 11, add sum of these two into prefix sum of 9, you would get prefix sum of 11. Prefix sum of 3, you get sum of these two elements into prefix sum of 1, you get prefix sum of 3. Okay, and once you have prefix sum of every two elements, you can easily compute the prefix sum of every other element, right? So to compute the prefix sum of 2, you add the 1 into prefix sum of it, right? To get the prefix sum of 6, you already know the prefix sum of 5, you add 5 into that, you get the prefix sum of 6, right? So to for compute the prefix sum of 14, You take prefix sum of 13, you add 13 into it, you get prefix sum of 14. Great. Okay, so let's start with the downsweep operation then. So we have 0 here, and we copy this 36 here. So remember, the downsweep operation looks something like this. We have to L and R, we copy R, we add L and R together to get new right element. Okay, again I assume that you already know this. So remember, I explained that we would compute this prefix sum of 9 and prefix sum of 1. So that is this, what is this algorithm is doing now. So we copy 0 here and we add 36 to 0, we get 36. So this 0 is prefix sum, we know by definition it's a prefix sum of 1, right? Let's now look at why this 36 is coming from, where this 36 is coming from. So this 36 is 36 plus 0, 36. This 36 is here, which was copied from here. So this is 36, which is the sum of these 8 elements, right? That is prefix sum of 9. So it's a sum of 10 plus 26. 10 is first 4 number summation. 26 is this 4 number summation. So when we add these two together, we get sum of first 8 numbers. So that is why this 36 is in fact prefix sum of 9. So now we have prefix sum of the boundary, this boundary and this boundary. We will use those to compute the prefix sum of these new boundaries, right? So let's see how this algorithm does that. Okay, so it copies this 10 here, it copies this 42 here, right? Then again it's just that downsweep operation. We copy that guy here and add this to here, copy this here and add this to here, right? So that is 78. So we know that this 36 is associated with this boundary, and we know that this 0 is associated with this boundary, right? Now let's see how this 10 came into the picture. That 10 was the summation of this plus this, right? So this is just sum of first 4 elements. So we added it to 0, which was the prefix sum of 1. So prefix sum of this thing plus these 4 elements gives us the prefix sum of 5, right? So there we have prefix sum of 5. So we have already computed this now, right? Now let's look at this 78. How did we get 78? It was 42 plus 36. What is 36? 36 was the prefix of 9, right? And what was 42? 42 was the summation here. It's the summation of these 4 numbers. So we add 36, which is the prefix sum of 9, and 42, which is sum of these 4 elements. We add them together, we get the prefix sum of 13. So now we have prefix sum of this boundary as well, right? Now that we have prefix sum of these boundaries, we compute the prefix sum of new boundaries. This one, this one, this one, and this one. Okay, so let's see the algorithm details. We copy this 3 here, copy this 11 here, copy this 19 here, copy this 27 here. Then we apply downsweep. So we have this 0 here, 0, 3 plus 0 is 3, copy 10, add these two, get 21, 36, add these together, we get, what do we get? I think we get 55. Yeah, 78, we add these together, what do we get? We get 105, right? Okay, so again I know that this 0 was the prefix sum of 1. I knew that this 13 is the prefix sum of 5, right? This 36 was the prefix sum of 9. This 78, which was computed here, it's a prefix sum of 30, right? So let's look at uh, how this 3 came into the picture. This 3 was just 0, which was the prefix sum here, plus these two elements. So that way we have prefix sum here, prefix sum of sorry, my bad, prefix sum of 3, right? Similarly, this 10 was summation, sorry, this 21 was summation of 10 and okay, my bad, 10 and 11. 11 we know is the prefix sum of 5. We add this okay, sorry, my bad, 10 is the prefix sum of this 5, right? And we add 11 into it to get the prefix sum of 7. Okay, similarly we know that 36 is the prefix sum of 9. We add 19, these two elements, to get the prefix sum of 55. That is, remember, this 36 plus 19, this is the 19, these two elements we added into prefix sum to get 55. Similarly, this 27, this 78 was the prefix sum. We added 27, which was the sum of these two elements, to get this boundary, prefix sum of 15. Okay, so now we have prefix sum of every two elements. We can use them to compute the prefix sum of every element. Right, so copy 1, copy 3, copy 5, 7, 9, 11, 9, 11, 13, 15. Okay, we copy this 0 here. 1 plus 0 is 1. 3, 3 plus 3 is 6. 10, 10 plus 5 is 15. 21 plus 7, 28. 36 plus 9, 45. 66. 78 plus 13 is 91. Believe. Yep. 105 plus 15 is 130. Right. I'll not explain the whole sequence, but I'll just pick one number randomly. Let's see this number. I think it was already there. Let's see this number. Right. So that is copy of 78, and this 91 was 13 plus 70. So 78 was the prefix sum of what? It was the prefix sum of 11. I don't know. Okay, let's start from the beginning maybe. Yeah, so I had prefix sum of 1. I add 1 to get the prefix sum of 2, right? So which is just 1. Again, I had prefix sum of these two elements, which was 3. I added this sum, this 2. Sorry, I had prefix sum of these two elements, right, which was 3. I added 3 into it, so this is the 3. So 3 is 3 and 3 make it 6, right? So now I have prefix sum of 4. Yeah. Okay, now I had prefix sum of 5 here, which was 10. I add 5 into that, I get prefix sum of 6, right? I had prefix sum of 7, which was 21 here. I added 7 into that to get 28. So 28 is the prefix sum of 8. And you can extend this argument to all other argument. And finally, this argument, like we already had prefix sum of 15, which was 105. We added 15 into it, and we get prefix sum of 16. Alright, that's it to this algorithm.